Today's topic is a continuation of compound interest. We have already done 3 parts of it. Today is the 4th part. Now, if you have not seen the earlier 3 videos, the links are in the description box. Go through those videos because I have shown some shortcut methods, some different types of tricks. These would help you to solve the higher level problems in this video. All right, so let's get going. The difference between the compound interest and simple interest on rupees 6,400 for 2 years at 12.5% is, so you need to find the compound interest, simple interest, and then the difference. But that method is going to be very long. So we are going to use a shortcut method here. In my previous videos, I had shown you the tree method. So let's do this by the tree method. Now the first thing that you have, 12.5%, which is nothing but 12.5%. So how much is this? So this would be, now those who are not familiar, I'm showing you once again how to convert the percentage to a fraction. So this would be 25 upon 2 and the percentage in 200. So this would be 1 upon 8. Okay. So let's take the tree method. So you have 6,400. Now for the first year, what we are doing is calculating the compound interest. For the first year, it is going to be 1/8 of 6,400. So that would be 800. For the second year, again, it would be 800. So now what happens is, this becomes your simple interest. Then the compound interest, again, there would be a 1/8 on this. That is nothing but 100. So if you look at your total compound interest, it is going to be 800 plus 900 here. You need not even calculate because the difference between both would be 100 rupees only. Okay. Now this is the shortcut method. Don't find the compound interest and simple interest separately. That would be too long. Okay. So what is your correct answer? The difference between both is 100, and which is your option number D. Okay. Now there is a formula also which I have given you in my first video, how to calculate the difference for 2 years and 3 years. Now there is a direct formula. I'm writing it here. You can solve this. Even if you solve this, you will get the difference directly. Maybe later on in some sums, we may use the formulas. Okay. Let's go to the next sum. The difference between the compound interest and the simple interest on a sum for 3 years at 5% is rupees 122. Find the sum. So now here, in this case, you are given the difference. So let's use the formula. Now this formula I have given you in my first video. This is the formula for 3 years. So the difference is given as 122 into 100 into 100 into 100. I am cross multiplying, divided by P we need to find. R square is 25 into 305. So this will go 4 times, then 520, 561. So now 61 and 122 will cancel. So we have 160 in 200, which is nothing but 16,000. Now this formula, what I have given you, is for 3 years. In the previous sum, where the number of years was given to you as 2, we used the other formula. In fact, we didn't use it. I showed you that formula. Okay, and we did the sum by the tree method. Now, this is a very convenient formula that you can use. Okay, correct option in this case would be the D1. Let's go to the next sum. The difference between the compound interest and simple interest on rupees 18,000 for 2 years is rupees 405. Find the rate percent. Now again here you are given the difference, number of years is 2. You need to find the rate, but you are given the principal, unlike the second sum. So I'm going to use the formula here. Now this is for 2 years. All right, difference is 405. 100 squared would be 100 into 100, and principal is given as 18,000. We need to find R. This is R square. So 1, 2, 3. 2, 3 cancels. This will go 2 5s are 2 9s are 9 4s are 36, 9 5s are 45. So what you get here is 45 into 5, which is R square. So R will be under root 45 into 5, which I can split up and write it as 9 into 5 into 5. Square root. Square root of 9 is 3, and square root of 5 into 5 would be 5. And your correct option is the B option. Now, I have taken 2 sums where I have used the formulas. In the first sum, I have not used the formula, but I've used the tree method. So you have a number of options. You can use any of the option, the methods that I have shown you earlier. Okay, let's go to the next sum. Now this is a different type. Where I have marked the star is a different type. Find the compound interest on rupees 25,600 at 12.5% for 2 years, 6 months. This is the first sum where the number of years are not complete. What I mean by not complete is that you are given some months and some years. So we have 6 months here. I am going to calculate the compound interest for 3 years. But in the third year, I am going to only take it for 6 months. There is a formula which I have given you in the first video, but I am not going to use that. So the first thing we do is 12.5% is nothing but 1 upon 8. Okay, so let's take the tree method. Now, as I told you, I'm going to take it for 3 years. So 1/8 of 25600 is 8 3s are 24. So first year, second year and third year. Then again this would be 1/8. So that would be 400, 400 and a 400 from here. And then again a 1/8 from here. Okay. So you see what we have got here. In the first year, it is 3,200. In the second, it is but in the third, now the total that I have got here is 4,050. This is for 1 year. And what we need is to find for 6 months, because in our sum we are given 6 months. So for 6 months it is going to be divided by 2. Okay, so this would be for the 6 months. So now our total here, 8,825. Get this part very clear. I have found out for the whole of the third year. Then, since in our sum we are given only 6 months, which is half a year, I have divided by 2, and that's how I have got 2,025. So this would be the interest for the 6 months. And for the first year, second year, 3,200 for the first year from here, 3,200 plus 400, that is 3,600. So when you add all this, you get 8,825. So our correct option is the A option. Now we go to the next sum. Find the compound interest on rupees 50,000 at 6% for 1.5 years. So now this is much simpler. 50,000 at 6%. This is 3,000. Now here we are just given 1.5. So we don't take the third year, we only take the second year. And then again a 6% here. So this would be okay, but we need only half the year. So I'm going to divide this. Okay, so what we get final answer here, 3,000 for the first year, and for half a year I will get 1,590, which is nothing but 4,590. Now in both the sums, that is the previous one and this one, we have got half a year, and that is why we divide here by 2. That is for the interest for half year. Okay, so your correct option in this case is the D option. Okay, let's go to the next sum. Another slightly different sum. The compound interest on a certain sum for 1 year and 146 days. So now we don't have months, we have days here, at 14.28% per annum is 408. Find the sum. So now there are two different things here. One is you are given number of days. Second, you are given the compound interest and you need to find the sum. Okay. Now, I am going to solve this in a very different manner. First is 14.28%, as we all know, is nothing but 1 upon 7. You can calculate, you'll get it. So for 2 years, I am going to assume a principal which is going to be a multiple of 7. So I'm going to take twice. Also, 146 is nothing but number of days in a year, 365. So this will go 73 twice, 73 5 times. 2 upon 5. So in the principal, I am going to take 5. Why? Because I will be avoiding fractions, I will be avoiding decimals. So this is the principle that I'm going to take. Now let's do it by the tree method. Now this is the principle. So in the first year, I take 1/7 of this. So 1/7 of this would be 35. In the second, again I take a 1/7 of this. So this would be 5. Okay. $35 for the first year, 40 for the second. So now you see what was the reason for us to take this principle? We have avoided all the fractions and all the decimal parts here. Okay, so my interest for the second year is going to be 16 rupees. First year it is 35. Second year, which is nothing but only 2/5 of the year, and 2/5 of 40 gives us 16. So the total compound interest is 51 rupees. If the compound interest is 51, now principal is 7 into 7 into 5, which I have assumed. So if this is 408, how much is this? And you see this goes directly 8 times. Now you can multiply this. 8 5s are 40 into 49. It is 0. 9 4s are 36. 1960. So our correct option, 1960, our correct option is the C option. Let's go to the next sum. Again, we have number of days here. Find the compound interest on 10,800. Now here you're given the principal for 2 years and 73 days. So now you have got 73 days here and at a rate of 16 2/3%. Don't get confused at all. Very, very simple sum. First thing is 16 2/3%. Okay, now again I'm showing you those who do not remember. 16 threes are 48 and 250 upon 3 into 100. Why this 100 comes is because of this percentage. This is 1 upon 6. Okay, so let's take the tree method now. 10800, first year, second year, and we have to take the third year also. 1/6 of this, that is 1800, 1800, 1800. Then 1/6 of this, 300, 1/6 of this, 1/6 of this, and then you have a 1/6 of this, that is 50 rupees. So for the first year it is 1800. For the second we have 18 plus 300, so that is 2100. Now for the third, see what you have for the third. 18, 21, 24, 2450. Let's convert the number of days to years. So we have 73 days divided by 365. This goes directly 5 times. So 2450 divided by 5, which comes from here. This is 490. So add my third year's interest. So now when you add all this total, it comes to 4390. Okay, now get this very clear, very clear, why we divide the third year's interest by 5, because it is only 1/5 of the year. Okay, so your correct option is the A option. Okay, let's go to the next sum. The amount on rupees 8,000 for 2 years is rupees 8,820 compounded annually. Find the rate percent. Now, there are 2-3 methods how to do this. So I will first show you by the formula method. We have a formula. Amount is principal 1 plus r upon 100 raised to n. So amount is given as 8820. I will divide by the principal here, and this is 1 plus r upon 100 raised to 2. Now if you look at this, this goes cancel by 2. So basically what you're going to do here is take the square root. Why square root? Because it is for 2 years. Square root of 441 upon 400. So 21 upon 20. I can take the 1 here. So minus 1 is equal to r upon 100. So this becomes 1 upon 20 into 100, and that is your rate percent. Okay, now I have shown you how to use the formula to get this, but you can do it directly. Now how to do it directly? Okay, the amount and the principal. whatever you have got the amount and the principal. So 8,820 upon, since it is for 2 years, take the square root, minus 1 into 100, and this will give you directly the rate percent, which is nothing but what we have got here. Okay, so if you work out this, you'll get the same thing as what I have done earlier. Okay, this is the easier way to do it without even bothering to use the formula. Okay, so your correct option is the D option. Okay, let's go to the next sum. Rupees 225 becomes 256 in 2 years. Find the rate percent per annum. Now here, what I explained to you earlier. This is a hint that I am giving you. Take the square root. So directly I am going to take the square root of the amount upon the principal minus 1 into 100. This will give me the rate percent directly. So 256 is 225 is 15, 256 is 16, minus 1 into 100. So this will be 1 upon 15 into 100 is your rate percent. 5 threes are. So R will be nothing but 6 2 upon 3%. Alright. Now, supposing you were given 3 years, then you take the cube root. Correct option over here is the A option. Okay. Let's go to the next sum. Rupees 1024 becomes 1458 in 3 years. So now in this sum, we have 3 years. Okay, like what hint I have given you here. This is the hint that is there. This will not be given to you in the exams. Just for you to follow the video, I have given you the hints what to do for 2 years and what to do for 3 years. So I am going to directly take the cube root of the amount divided by the principal. Now, how do I get this? I have already shown you in the first sum by using the formula. Okay, so this will go to 512. So cube root of 729 upon 512 minus 1 into 100. So the cube root of 729 is 9. Cube root of 512 is 8 minus 1 into 100. So this will be 1 upon 8 into 100. 4 twos are 425. So R will be 12.5%, or what we have got in our option as 12.5%. So your correct option in this case is the A option. Okay, let's go to the next sum. Now here again we have got 3 years. Rupees 1600 becomes 1852.20 in 3 years. Find the rate percent. So we'll take the cube root of 1852.20 upon 1600 minus 1 into 100. This will be your rate. The first thing that you do is get rid of the decimal place here. What I have done is I have taken out this decimal from here. That is why I have put this extra 0 here. Okay. Now you can cancel by 2. So 2 9s are 2 2s are 2 6 and 2 8 0 0 0. Now this is cube root of all. Cube root of 9261 upon cube root of this. So this will be 21 upon 20 minus 1 into 100. See how simple it becomes. So this will be 1 upon 20 into 100. This is nothing but 5%. Correct option is the A option. Okay, let's go to the next sum. The compound interest on a certain sum for the 15th year is 6,500 and for the 18th year is 8,651.5. Find the rate percent. Now, even if you are given 15th year and 18th year, what it amounts to or what this means is that 15th year, the 6,500 has become this amount in 3 years. So basically, what happens over here, the amount becomes 8651.50 and the principal becomes this in 3 years. From the 15th to the 18th, it becomes 3 years. So wording is different, but the meaning of the sum is the same. You have to interpret it that way. So like the previous sum, I will remove the decimal from the numerator. 86515. One decimal I have shifted. Now this cancels directly by 65. Now cube root of 1331 is 11. So you'll get 11 upon 10 minus 1 into 100. So which amounts to 1 upon 10 into 100, which is nothing but 10%. Correct option is the C option. I have taken today different types of sums. Okay. Now, the other videos I'll be taking some more advanced type of sums. Okay. Do not forget to like, subscribe and share my video. Share this video with your friends so that they can also take advantage and learn how to solve some complicated problems using shortcut methods.